All right, welcome for the quotient rule there, calculus folks. What's weird about the quotient rule is some of you just won't ever use it. Well, sometimes you have to, but in ones like this, there'll be some of you that will do it exactly like you've done it in the warm-up. We'll see the new rule, the quotient rule soon. But the idea is I can write a quotient as a product and then just take the derivative. And so hopefully you tried this, right? Take the derivative of the first thing, write down the second thing, write down the first thing, derivative of the second thing, tidy up, which is nasty since you got fractions, right? Um, Negative exponents means fractions, and then you got to get a common denominator and tidy up, and hopefully that's what you got. Okay. Um, but there is the quotient rule. Okay, so the quotient rule is if I have a function that's the quotient of two other functions, what's the fast rule? And it's not that pleasant. We're going to develop the quotient rule using the product rule. So I can write q at x as f at x times g at x to the minus 1, right? These are the same expressions. And so if I'm going to take the derivative of this now, take the derivative of the first thing, write down the second thing, plus write down the first thing, derivative of the second thing. So the derivative of the second thing here, well, that's a power of a function rule. The minus 1 comes down. Write down the inside thing, which is the g at x. Subtract 1 off the exponents, and then I got to take the derivative of the inside thing. Derivative of the inside thing is just g prime at x. Now let's tidy. The dreaded tidy. That goes on the bottom. Plus, what's all the positive stuff here? I got that. That becomes a minus. So where should I write the minus? Let me write the minus out front here. Okay. It's going to be a minus because of that minus. What else do I got? Well, that's got to be in the bottom. Minus 2 means that's squared, and then I write down. Well, common denominator, multiply this by the missing factor, which is g at x. So f prime at x, g at x, minus, oh, that's squared now, right? Because I got my common denominator. And so I have, and actually this is a pretty nice pattern. Almost looks familiar. The top almost looks like the product rule. Well, it is the product rule, right? That's what we use, but that's the rule. So when I have a quotient function, and here is the quotient function, I go derivative of the top, write down the bottom. Subtract, think of that negative exponent, that's where the subtract comes. Write down the top, derivative of the bottom, all over the bottom squared. That's the quotient rule. It's not pretty, but that's the quotient rule. So in Leibniz notation, what would we have? The derivative of a quotient is d high, write down the low, minus, write down the high, d low, over low squared. D high, write down the low, minus high, d low. Low means on the bottom, and then the low all over the low squared. That's in Leibniz notation. So let's see this bad boy, the quotient rule, in action. Okay, there's your product rule or your quotient rule. So what do we got? Find dy by dx. So notice if I think of this as a quotient, I could think of this as u equals 2x. Then the derivative of the top is just 2. And if the bottom is x plus 3, then the derivative of the bottom is just 1, right? And so here we go. Dy by dx, I'm using Liveness notation. Derivative of the top, right down the bottom. Right? Derivative of the top, right down the bottom. Minus, right down the top, right down the top. Derivative of the bottom, which is just 1. All over the bottom squared. Notice what's nice is I don't have to get a common denominator. I don't have to do any of that. I got a little bit of algebra to take care of in the top, but that's no big whoop. Dandy. Easy. Example 3. Find the derivative of that at x equals 5. Notice that 2 pieces. I could tackle this in any number of ways. It might be your instinct to multiply this out, get a common denominator, and so I'd get g at x is equal to, one polynomial function over another polynomial function, and then I can use. Sorry about that there, folks. I tripped on my microphone and unplugged it there for a second. Or, and this is maybe what I'm going to do. You certainly could do this, and that's a bit nasty. I'd need to multiply this out, common denominator, and then I could certainly get it like this, and then use the quotient rule like I just did there. But at least this first term, why don't I try and rewrite this? Why don't I be smart about this? Write it like that. This first term should be easy. Now, the second is a bit nasty, and if I wanted to multiply this out, I certainly could. But I'm going to think of this just as the quotient rule here. Here's my f, and here is my u or my p, and here's my q. So I'm going to do them in 2 pieces and see how that turns out. And I want to find the derivative at x equals 5, so I'm going to do that later. This is just a polynomial part, and that's why my instincts was to do this. The -1 comes down, subtract there, and now here's my quotient rule. Derivative of the top. This is a product of a function. Derivative of the top. The 2 comes down. And then I got to take the derivative of the inside part. The inside part is that. And so this is all the derivative of the top. This is all kind of my top part. If this is p, this is p prime. So derivative of the top, right down the bottom. Minus, right down the top, right down the top, derivative of the bottom. Well, the derivative of the bottom in this case is easy because the derivative of the bottom is just 4. And then all over the bottom squared. And notice, yeah, I got some nasty multiple. I got this. If I wanted to tidy this all up, it would be kind of a mess. But look carefully here. There's something strange afoot. When x equals 5, and I'm looking in here, this is going to be 25 minus 25. And this is kind of nice. This happens a lot for us, by the way. When x equals 5, I get -50 over x squared is 5 squared on the bottom. But then this is going to be 2 times 25, that's going to be 0. And then I don't really care about any of this rest of this stuff because all this stuff is going to be, this is all wiped out by this 0. Minus, this is going to be 0 as well, right? That's going to be 0. And then who cares about the bottom? I don't really care about the bottom because what's going to happen? 0 minus 0, this is all 0. That's all 0. And so what do I have? I've got -50 over 25, that's minus 2. Pretty nice, actually. I'm glad I didn't expand all this stuff, collect like terms, because that turned out to be not that difficult. So notice, what does this mean? At 5, the slope of this nasty big thing is minus 2. What's example 4? Find the equation of the tangent to... Okay. Look what we got here. If I think of this as f at x and this as g at x, I'd have, I'd have to take the derivative of the top, and the derivative of the top I could think of as a product rule. The bottom is another product rule. So all these derivatives are product rules, which, oh boy, that sounds like a lot of work. I wonder if I can make my life easier here. And these are just instincts you need to build up, folks. I'm just going to multiply this out and watch this gets way better. Well, see, now that's easy. This isn't a product rule anymore, right? On the top. It's a quotient rule overall, where my f is just a polynomial function. Take the derivative of the top, 4x plus 1, right down the bottom, minus, right down the top, derivative of the bottom, all over the bottom squared. Now, the bottom squared is not much fun, but maybe things will be okay. Do I have to multiply all this out? Well, it's kind of nice when I can substitute a point in, instead of doing all the algebra, especially with ones, it might be easier just to do that substitution. When x is 1, well, let's make this smaller so I can read it, okay. Wow, that's awful. Okay, Restal, there you go. When x equals 1, y prime is equal to 4 plus 1 squared plus 4. I'm doing a little of this arithmetic in my head because I can. Right? This is 2 times 1. Yeah, good, all good, all good. All over 1 plus 4 plus 3 all squared. This isn't so bad. I don't even need my calculator. This is 5 times 1 plus 7 is 8 minus 3 times 6 all over, what's that? That's 8 squared, 64. 40 minus 18. 40 minus 18 is 22 over 64. Lowest terms, 11 over 32. Check my notes, see if I got 11 over 32. Find the equation. Oh, isn't that fun? Isn't that fun? Because we've got more work to do. Well, started this earlier. I'm going to have to move it down, move her down, move her down. Smartboard magic. So that's my slope. What do I got? I got x equals 1. What's the y value? Well, I put her back in up here. Y is equal to, when x is 1, y is 3 on the top. On the bottom, I got 8 on the bottom, I think. Yes? I think. Yep, 3 eighths. Are you nodding out there? Good, thank you. And then I need to substitute that into my y equals mx plus b form, or I'm going to use slope point form this time. Just change things up, I guess. X minus 1. Multiply by 32 to kill all the fractions. That's 4, so that's going to be 12. 11, x minus 1, kill all the fractions. There's only one term there, so this is going to be 32y minus 12 equals 11x minus 11. Put everything on one side for standard form. Add plus 1. Plus 1. Oh, that's what I got on my notes, so I think I'm okay for my arithmetic. Um, if you use y equals mx plus b, that's fine too. Example 5 I'm not going to do because there's one example like this. They do it, well, it's almost exactly the same example. The numbers are a little bit changed on page 96 where they use the quotient rule with one of these fractional exponents, one of these radical ones. I want to mention, when it's only one term, again, make your life simpler. The quotient rule is hard to remember, right? If I sort of treated this like one of the first day ones and simplify it, try and, what happened here? Why is it all squished? Oh yeah, that's right. I moved that down, didn't I? Oh boy. Made a mess of things. Made a mess of things. See if I can move this down. Can I move this down now? All right. Almost. There, that's not so bad. No, no. There we go. Get that out of the way. Need you later. So the idea of this plus this, I can simplify it, right? And then this is just one of our easy derivative ones, right? Where the derivative, I can take the derivative and the half comes down. I've kind of made a mess of this, but right, once I take the derivative, I'll do it again. I was going to just not do this at all, but take the derivative of, again, this is 3 halves x to the exponent 1 over 2. The derivative comes down, becomes 4/3 times negative a half x to the minus. Now, the rest of this isn't very nice to solve, but um, it's not that bad. It's not that bad. Hopefully, I didn't erase too many of the steps. Um, Here's one of the steps that um, is involved. The 3 over 2. Notice this is square root of x on the bottom. This is uh, negative 2/3 because the 4 and the 2 cancel out a 2, and then this exponent on the bottom. And then there's some fancy algebra to help solve this, but essentially this goes on the other side. You can cross multiply as long as x is not equal to 0. You can cross multiply. You end up with a quadratic, no, a cubic that factors, but x equals 0. You can't have that as a solution. You can't have a negative solution because you can't have a negative underneath the square root, and you end up with the one horizontal tangent at x equals 4/9. And there's an example in the book that uses the quotient rule. Notice that the derivative itself was right there. I didn't need the quotient rule. This was pretty hard. The derivative was actually pretty easy. And I want to prove to you that I didn't goof up the arithmetic because I pounded that into to Desmos, and look, there's the 4/9, and there's the minimum. Okay, all right, dandy. That's quotient rule, and was that one video? Quotient rule in one video? Holy moly! One super long video, but it was one video.